Good day. My name is Sylvain Rachon. I am the Paradise Engineer, and I have another episode for you. And this is about the search for extraterrestrial intelligence out there. What are we doing currently? Well, I think there's two aspects of what we're doing currently, where there is a bunch of scientific projects that are like ground-based, like surrounding NASA and really formal organizations that are about looking for extraterrestrial life in general, not necessarily intelligence, just see if is there life on other planets. And that is led by the James Webb Space Telescope. Since its launch has been looking for biosignatures. What does that mean? It means that it's a telescope that's been designed to look in the infrared spectrum, but also it's able to quite successfully parse out the spectra from suns that as they pass through alien or extraterrestrial atmospheres, so exoplanets. So it's very good at identifying exoplanets. And then one point of interest of exoplanets is to be able to see, well, is there an atmosphere? What's the planet's composition and so on? And while we're at it, since we can detect the spectra of the atmosphere, we can detect what are the chemicals in there. And interestingly, as a byproduct of that, when you look at an atmosphere, there's certain compounds are indicators of life. So you're able to see if there's a high probability of these planets to have actual life on it. Because normally, if there's no life or no industrial activity or anything whatsoever, really chemically active chemicals don't persist in high quantities in the atmosphere. Like the Earth is an example. There's 21% of our atmosphere is oxygen. Oxygen is reactive. It's reactive, like it can burn, it can interact with oxidizes iron. I mean, it does a lot of stuff. So, but we have plants that create oxygen. That's why we have so much oxygen, and it's consumed by the Earth and also living beings on the planet Earth. So if you find high quantities of oxygen on an exoplanet, there's a high likelihood that there's something that produces oxygen. So either industry, which could be entirely robotic, which is indicative of intelligent life, because industry can't occur without that, or some kind of biology that generates the oxygen. Now, there is a planet that's of interest right now, and I have to look in my notes because I forget the name of it. K218b recently has identified, we were able to identify dimethyl sulfide in that planet's atmosphere. And that's a very reactive chemical, and it's in significant quantities. So the scientists are wondering, well, maybe there is something that produces that, life or industry or something like that. It's a big question mark since the planet is very, very far away. We can't really check and validate that. But the James Webb Telescope is looking for life. We also had the Cassini probe within our own solar system looking at Enceladus, which is one of the Neptune's moons. It has lots of water underneath, and we discovered from that mission that there's the conditions inside that ocean underneath the crust of ice is actually excellent for life. You could have life down there. All the components of life are there, like chemically. I mean, the atoms like carbon, nitrogen, oxygen, hydrogen, and liquid water, of course. So there could be life down there. We just don't know. The conditions are pretty good underneath that ice for life, and it remains to be seen. Now, on the other component of it is we're looking for intelligent life. So traditionally, we have SETI, like the search for extraterrestrial intelligence, that's been scanning the Earth and receiving signals and analyzing signals. And that's an old challenge. It's also a very big challenge in the sense that we're assuming that we're going to receive radio signals which travel at the speed of light within a reasonable amount of time. So, I mean, since light travels at 1 light year per year, if you can call it that, then since we established SETI, I think it's in the 70s, it can only see or hear what's been going on up to 50 light years away, or give or take, right? So that means that we're listening for radio signals or communications that are in our vicinity, because otherwise it's impossible. Light just travels so fast, it doesn't reach us, so we can't. That's a very, very small proportion of the galaxy. But the closest solar systems are covered. The other assumption of receiving some kind of signal is that the technology that is used by whatever civilization is within that possibility bubble of distance actually uses these kind of signals to communicate or to emit, transmit, like TV would do it, anything like that. So if it's a highly advanced civilization, if it's more advanced than us, it may be using completely different technology, not using radio signals at all, and not emitting anything like that. So we wouldn't detect anything recognizable if that's the case. If the civilization is too primitive, it doesn't use or produce radio wave in any way, and then we can't detect that. So there's a very short window within the civilization, presumably, that we would be able to detect within that bubble. Now, the third thing is, I've talked about this in the previous video, is that we also have to assume that other civilizations out there that, let's say, they're aware of us, are allowing signals from other civilizations or themselves to reach Earth. Maybe they're trying to keep everything quiet on purpose, so we're not receiving anything because it's been disrupted. That's a possibility. We don't know, because that depends on the purposes of ETs. But I've talked about the Fermi paradox and the preserve or the zoo hypothesis. Under that hypothesis, well, it's fairly likely as they don't want to have any disruption until they're ready to make a contact and kind of create disturbance in the society that wouldn't ensue after that. And finally, this is 2021 or so, after the object Oumuamua passed through our solar system, and Dr. Avi Loeb from Harvard published his book, Extraterrestrial. He's been raising funds and doing some interesting research with other scientists to try to detect techno-signals. So Oumuamua, he said, was probably some kind of debris or some kind of object that came from a different civilization that was made, possibly. So he's trying to detect more of those in the sky, but also he's looking at the oceans of asteroids that have, or presumably asteroids that have fallen, that may not have been asteroids. Maybe they were made by another civilization, like an actual object made of materials that would survive the entry, so some metals. And looking for the metallic debris, basically, and analyzing that debris to see, because we can detect if it comes from Earth or it comes from somebody else, from the isotopes, from another planet, for example. If it does come from another planet or another place we don't know about, then it's possibly it was something that was fabricated or at least comes from an entirely different place, and the metal analysis would also indicate if it's natural or if it was machined, something like that. So he's looking for all these signs. And this is all really, really good because we want scientists to be free and open to explore these questions. And for the longest time, and still even today, it's still a lot of scientists that are exploring these avenues are on the fringe. They're edge. They're not considered serious by some sometimes because it's a bit frivolous. It's hard to get proof and so on. So, but now, because of disclosure, because of all sorts of movements, because of personal experiences and observations, more and more scientists are actually putting some serious money and time into their methodologies to find proof and to publish and talk about the proof as authorities. And that helps us as an organization with the Alliance, and helps humanity in exploring in an open fashion all these possibilities. So let's encourage those scientists and those efforts all the time. Thank you for watching.